Section 4.4, translation of conics. Main difference between this section and the other one is the coordinates of the center has changed. It's not on 0 and 0 anymore. So when we want to start to find the center has coordinates of h and k. So the whole thing would translate or move to the right, left, up, and down. There are two equations for ellipse, very similar to what we had before. Again, the only difference is here you have h and k, which is the coordinates of the new center instead of 0 and 0. We also have for hyperbola and for parabola. So we need again to have this page while you're working on the homework assignment. Like in this example, the first one on page 342 of your textbook. This is the equation of the circle. The center of the circle is 1 and -2. It's always opposite of the sign that you have here. So 1 and -2 is the coordinates of the center. Then from this point or from the center, we draw a circle with the radius of the 3. Or this one, it's the ellipse. And to see which one it is, here, what you have under the X, this is what you select on the X-axis. So 3. So first you find the center, which is 2 and 1. And then from here, you go 3 to the left, 3 to the right. Under Y is 2 to the power of 2. So you move up 2 units, up 2 units down. They give you 4 vertices of the ellipse, and then you draw your graph. They also have it for hyperbola here. This one, the C, is for this one. For the hyperbola, again, the center is 3 and 2. So remember, it's always opposite sign of what you see in the parentheses, like x -3. So x is 3, opposite of that, 3. Y -2, opposite of -2 is +2. So the coordinates of the center is 3 and 2. And then under the x, you have 1. So from this point, you go 1 unit to the right, 1 unit to the left, and then as far as the y is 3, under the y there is 3. So you go up 3 units and down 3 units, you draw a rectangle here. When you draw the rectangle, then you draw bisector of this rectangle, and that would give you the hyperbola. So again, for something like this, the main difference between hyperbola and ellipse is hyperbola has a negative sign instead of positive. Like if I change this to positive, then it's ellipse. So for that, on the x and y axis, first you find the coordinates. This is 3 and 2, is 1, 2, 3, and 1, 2. This is the center. This is the center of the hyperbola. Then under the x is 1. So you go 1 unit here, 1 unit there. And then under y is 3. So you from this center, you go up 1, 2, 3 here, 1, 2, 3, 3 up, 3 down. Now you create a rectangle here. Then diagonal of this rectangle is the asymptotes. Now we need to know whether we should go right or left. Then you look at the picture here, that in the hyperbola, when you start with x minus h, then it's right and left. See that X? And here I have the X. So right and left is, this is the vertices of the one piece of the hyperbola. So you draw a long curve, which is, this curve is coming and is tangent to this line. Or here is one of the vertices. So from here you draw the curve, which is tangent to this line, and here goes, and it's tangent to this line. Okay? So go from the vertices and you draw the curve, which is going parallel to this line and parallel to this line. To the asymptotes. These are the asymptotes. These lines are the asymptotes. So when you draw your rectangle and you have the diagonal or bisector, these are your asymptotes. The other one, the other examples, which is D. D is, you have x to power of 2, but here is y1. So when you have x to power of 2, but y power of y is 1, then it's neither ellipse nor hyperbola. Ellipse and hyperbola both have x2 and y2. The other one that doesn't have, like this one has y2 but x1, or this one has x2 by y1. This is the case of the problem. Okay, if the problem starts with x to power of 2, in fact it's x to minus 2 to power, but if x to power of 2, then it would be this kind. And depending on the p, if the p-value or p-value is positive, then the parabola is like this. If p-value is negative, the parabola open downward. See, like this one? In the beginning, I have x2 by y1. So that means it is a parabola, but you have to work on it. You have to somehow write it in this format. Okay, so in these problems, when you have x2 minus 2x and you have 4y minus 3, here we had something like method of completing the square in intermediate algebra. You take half of these 2, which is 1, raise it to power of 2, add and subtract. It's like you are adding 1 and negative 1. You are not doing any change. But then the first 3 is x minus 1 to power of 2. You know, we have this formula, a minus b to power of 2 is a2 minus ab plus b2. And if you have a positive, then everything would be positive. So it would be a2 plus 2ab plus b2. And here there is a 2 as well. So the first 3 is this, x minus 1 to power of 2, and then minus 1 plus 4y minus 3, which is x minus 1 to power of 2 plus 4y minus 4. And then you take these 2 to the other side. So you finally write it like this. X minus 1 to power of 2 is minus 4y minus 1, which is this type of parabola. When you have a parabola like that, which starts with x, then all the informations are here. Focus is this, directrix is this, vertex is the horizontal, the vertex is this point, and so on. Like this one, find the standard form of the equation, the parabola, vertex is 2 and 1, whose focus is 4 and 1. Since focus is here, then it has to be this kind of parabola. This is the only kind that focus is on the horizontal axis. If the focus has to be On vertical, then this is a formula. But here, since they are saying that focus is 4 and 1, so you know that is this kind. Especially because when P, 4P is 8, right? Since this is positive, parabola open always to the right. Now here, when P is greater than 0, or when P is positive, parabola open to the right. If this P happen to be negative, then this opening would be to the left. Same thing here. If the value of the P, or 4P, is positive, the parabola open upward. If this 4P happen to be negative, then the parabola open downward. Again, this is the type of problem that first you have to use that rule I was telling you and write it like this. And then you have to divide everything by 4 because the ellipse has to have 1 here. Again, here, how do I come up with that? First, you have to group x2 and 6x next to each other, 4y2 and minus 8y here, and you take the number to the other side. And you factor 4 out here. Now you take half of 6, which is 3. Half of 6 is 3. 3 to power of 2 is 9. So you put a 9 here and then 9 on the other side. Then what is half of 2? 1. 1 to power of 2 is 1. You put 1 here and you take the 1 to the other side. And that's how you came up with the ellipse. And again, under the x is 2. So from the, what is the center opposite of this? Negative 3 and 1. So negative 3 and 1. Under x is 2. So you got 2 units and 1 unit up, 2 units to the right, 2 units, 1 unit up, 1 unit left, and have the problem. This is the ellipse is a vertical one. Minor axis is 4. Minor axes are this one, which is 2a. See here? If you have this kind of ellipse, then from here to here is 2a, from here to here is 2b. If you have this kind of ellipse, then from here to here is 2b, and from here to here is 2a. Which one is this one? Is that this one is this one. Okay, so 2a is from here to here, which is 6. 2a is 6, a is 3. Again, this is a type that you have to take half of 4, which is 2. 2 to power of 2 is 4. You put 4 here and 4 on that side. Half of 6 is 3. 3 to power of 2 is 9. You put a 9 here and 9 on that side. See, 9 here and 9 also on the other side. And to have always 1, you divide everything by 9. If you have a negative, then it's a hyperbola. Which kind of hyperbola is it? That they start with y? Hyperbola that they start with y is this one. This is another one. See, in this one, they are saying that vertices is 2 and negative 2. So it's 2 and negative 2. And 2 and 4. 2 and 4. So this is one vertex, vertex is 2 and negative 2. The other vertex is 2 and 4. This 2. And then there are foci. Foci is 2 and negative 3, and 2 and 5. The formula for foci is h, comma, k plus c, and k minus c. So k plus c is the negative 3, k minus c is the 5. If you solve this the equation, that gives you the value of c and value of k. You put into this formula. You have c, you have a, that gives you the value of b. You put it into equation. So on the homework assignment, the first one is the horizontal. So what is it? This was a circle here, which you shifted to the left 5 units. And the coordinates of this center is not 0, 0 anymore. It's negative 5, 1, 1. And I show you this one is the parabola. So the formula for the parabola, remember, it's see how you have x minus h to power of 2? That is this one. So x minus h to power of 2, there is no number next to it, right? So you have to move this negative 12 to the other side by dividing. That's what I did here. So now this formula is similar to this one. This formula, I wrote it here. So you could compare and find your p-value. And since p-value is negative, the parabola going down. This one, it's the hyperbola because it has a negative sign. And since you don't see any denominator, just assume denominator is 1 to power of 2. This is a hyperbola that starts with y. If the hyperbola starts with y, then it's open up and down. This is ellipse. Why? Because equation of the ellipse is there is a plus here. Plus is the ellipse. And coordinates is opposite of this, negative 3 and negative 2. So we start with negative 3 and negative 2. Negative 3 and negative 2 is the center of the ellipse, right? So then you go 2 here, 2 there, 5 up, 5 down. So you find the center first, which is negative 3 for the x. So here is the center is negative 3 comma positive 2. That's the center, right? And then under x is 2 to power of 4. Instead of 4, you could just write 2 to power of 2. So in fact, it's this like x plus 3 to power of 2, 2 to power of 2 plus y plus 2 to power of 2, 5 to power of 2 equal to 1. So from the center, you go 2 units here, 2 units there. Under y is 5. You go 5 unit up, 5 unit down. These give you 4 vertices. 4 vertices of ellipse, okay, which are here. 2, 3, 4. This one is the circle. It's very easy because x2 plus y2 is 8 to power of 2. What's the center of this? 0, 0. It's a circle. The radius is 5. This is another one. This one, you got to work on it. Again, I'll show you how you write it. See here? You take half of 2, which is 1, 1 to power of 2 minus 1 power. And then this 3 is x minus 1 to power of 2 minus 1. Half of 16 is 8. So you add 8 to power of 2, subtract 8 to power of 2. Then this 3 is y plus 8 to power of 2 minus 64. Then you take minus 1 and minus 64, move both of them to the other side. Then you find your circle. This is a circle. What's the center of this circle? 1 and negative 8. This is a long one, and first I divide everything by 4 because you don't want to have coefficient of x2 and y2 should always be 1. And then you group them. You put x next to each other and y next to each other. And then what is half of 3? 3 half to power of 2 and minus 3 half to power of 2. So you always look at the coefficient or number sitting next to x. You take half of that and raise it to power of 2 and subtract. Half of 6 is 3. 3 to power of 2 minus 3 to power of 2. Then this 3 is that, and this 3 is that one. And then you take these two numbers on the other side. That finally give you a circle. If I didn't have the 8, I would say this is, and I had a power of 2, this was circle, but it's not. You have x2 and you have y1, then that means it's the parabola. What kind of parabola? You write the formula, the parabola that has x2 and y1. So you write this under that, you take the whole thing, positive 8, take it to the other side. That tells you that when you compare 4p is negative 8 or p is 2, or I'm sorry, the negative 2, and then h and k is 1 and negative 2. So the vertex is this. And how do I find the focus on this kind of parabola? This kind of parabola, which start with h minus h, this is the one. So the focus is h comma k plus p. H comma k plus p. See, as soon as you realize the formula, then you could go through all this. See, what is the directrix? Directrix is y equal k minus p. What is the focus? H comma k plus p. So you write all this here because you have all the information, you plug in. Okay? So then the same thing, this is another one. It's very similar to this, but this has y2 and x1. When you have y2 and x1, then this is a formula. How do you find the focus? Is h plus p comma k. What is the directrix? Directrix is a vertical line, which the equation is h minus p. Vertex is h and k. See, you write all this here. You write the general equations, and then you want to have here under that tell you the value of k, h, and p. You find all these three, and then you put it in the proper formula. You pick all this formula, focus h plus p and k, directrix x equal h minus p from this one. So a minute you realize what kind of parabola or hyperbola or ellipse is, refer to this page and find all the equations. See, again, this one has y2 and x1. It doesn't have x2. So if it's y2 and x, that means is the parabola. Which one is start with y2 and x1? This one. So this is a formula. But first you gotta rewrite this, so y2 plus 6y, and half of 6 is 3 to power of 2 minus 3 to power of 2. And you take the minus 8x, positive 8x and positive 25, you take it to the other side, so both become negative. I'm sorry, it's kind of messy here. But now y plus 3, this is 3. Y plus 3 is minus 8, you factor minus x plus 2. You write the general equations under. You know the vertex is this. Focus is h plus p and k. Directrix is xh. You get all these from this one. And here I have the solution for number 13. Vertex and focus. You know, if for you to see which one is, first you got to plot this. On the X and Y axis, I see that here focus is 1 and 1, and vertex is 6 and 1. So that tells me that it's kind of parabola. Why is this one? Why is this one? Because focus and vertex both are on the horizontal line. So this is the right formula. Focus is h plus p and k. And what is given in the problem, when they give you a coordinates of focus, which is this, that means h plus p is 1 and k is 1. Vertex is given, you know, vertex of this kind is h and k. So h and k given is 6 and 1. So k is 1, h is 1. We also give you the vertex, so that gives you h and k. So you have all the information here. You have k, you have h. See, h plus p equal 1. Why? Because the coordinates of the focus as given in the problem, they say 1 and 1. We know focus is h plus p, so h plus p is 1. And we know already h is 6, so you put that here. That gives you the value of p, put it back here. Same thing for 14. First, you got to plot it. Vertex is 0 and 6. This is the vertex. And directrix is y equals something. When directrix is y, then you write a formula, h and k. So it's 0 and 6. So you put those two here, you put the p here, and that gives you the equations. See, because this is the only one. This is a parabola that has the vertex is on the y. And focus also is on the horizontal axis. That's why you figure is this formula. And then 15 is the last one. I'll show you the problem 15 here. See, in 15, when they say directrix is x equal -3 and focus is 3 and 3, x equals, so see is this one, because x equal is the directrix. Okay, so you put that one here, and I have the solution for number 15 on this page. Okay, so that would be end of this one.